Hi everyone, welcome to our series of PMT review. Today we are going to be looking at a very important topic, Ohm's Law. And I'm going to partition this topic in 3 dimensions. First of all, we are going to look at the historical background of how this law came about. Secondly, we are going to look at the benefit of Ohm's Law in our technologically advanced dispensation. And lastly, we are going to look at how to break down Ohm's Law to the layman level so that we will be able to explain Ohm's Law the way a layman will explain Ohm's Law. Now, the first subtopic is a historical review. Ohm's Law was postulated by a German physician by name George Simon Ohms in the year 1827. And this man, after running series of experiments, he was able to come up with a relationship between the current I, the voltage V, and resistance R. In layman terms, he defined Ohm's law as the current release is directly proportional to the voltage and inversely proportional to the resistance. Scientifically, this was how he defined Ohm's law. He said Ohm's law states that the quantity of electricity passing through a metallic conductor is directly proportional to its potential difference, V, and inversely proportional to the resistance, R. So he was able to connect the relationship between current, voltage, and the resistance. So I'm going to take off the whiteboard to explain these parameters further. So in a nutshell, I said Ohms was centered on tying these 3 parameters together, the voltage, the current, and the resistance. And according to his law, he said the current discharge is directly proportional to the voltage and inversely proportional to the resistance. So if we put equality sign, mathematically it becomes current is voltage, because V times 1 is V, divided by R. So if from here, if we want to make voltage the subject of formula, V equals to current times resistance. And we want to make resistance the subject of the formula. Resistance is voltage divided by current. So this is how these 3 parameters can be found and how they are connected to Ohm's law. And these are the things that happen in our day-to-day home activities as far as electricity is concerned. We're going to look at the units of these 3 parameters and how their symbols look like. Current is measured in amp, and the symbol is A. Voltage is measured in volt, the symbol is V. Resistance is measured in ohms, and the symbol is omega. So this is the summary of the 3 parameters. I'm going to take us back to a pictorial view of how a layman will be able to explain Ohm's law. Now, I want us to take a look at these 3 individuals. The person in blue is the potential difference, which is the voltage. The voltage is stored in different vessels. For example, we have the dry cell, for example, which is an example of a dry cell is our Duracell battery, which we use in our remotes for our television. And they store charges in them, and they are in volt. So the batteries can be 1.5 volt, 3 volt, 6 volt, 4.5 volt. So they are called potential differences when they are still stored in the battery and they are not discharging in current. So every time you connect the batteries 2 or 3 together, you connect them in series, and you introduce a conductor to them, then it now turns from potential difference to EMF. Now, potential difference is the EMF when it is not discharging any current. It is when the charge is still stored in the battery and the battery is still sealed, is still in the shop. Hopefully, you've not bought the battery yet. So at that point, it is called volt, but in potential difference. Now, when you buy it, you unwrap the seal and you connect terminals to it. You will discover that at that time, it's no longer potential difference. It is now EMF, electromotive force. And at that time, when you put your 2 hands at the terminal, for example, if it is a charged car battery, which is a wet cell, it is going to shock you. So at that time, it's no longer potential difference. It is discharging the cell. And it is reducing from its charge and discharging and into current. And that is where current comes. So look at what's happening. The volt is now converted to EMF and is pushing the current through, and the resistance is trying to resist it. So resistances are example of the terminals where the electricity terminates. For example, our electric bulbs, our television, our electric cookers, our heaters, electric iron. So those are the resistance. So they pass, they impede, or they serve as terminals to electricity, and they generate something. So voltages are written on our dry cell, such as Duracell battery, on our wet cell, such as car batteries, and most times on our laptop chargers. When you want to buy laptop charger, there are transformers in this step down, because if the electricity that is released from hydroelectricity is powered directly into our homes without stepping them down to the required voltage, they are going to blow off most of our gadgets. So that is why they are stepped down to this. So that is the summary of what happens in our day-to-day home activities. So if you look at the circuit, this is how, after building your house, you want an electrician to come. This is what the electrician will be given. Because you did not study electricity, you would not know, it is not on the paper. But this is just a summary of what I showed you on that layman physical diagram. So an electrician will be given this. He knows that the voltage represents the source of electricity, could either be generator, hydroelectricity, or battery. Then he knows that the current is the one that flows. Now, when the electricity is passed to your house, the meter that the power generating source come to your house, they are going to go and check the meter. That's where the amp is. So it registers the amount of power that is being discharged into your house and the one you use. So it's the ammeter that is used to measure the amp that is being discharged to your house. And that is how bills are. It is converted into monetary terms and sent to you as a bill to pay at the end of the month. While the resistance is the power dissipating terminal, which I said earlier, it could either be your electric bulb, it could either be your television, or whatever. So that is how the circuit looks like scientifically or in terms of electric. What I showed you was the circuit diagram for a professional electrician. Now I want to step it down to our layman language so that I will define Ohm's law in our layman language using this picture as a case study. Now, looking at what you're seeing, you have seen Duracell batteries, so that I will not bore you with words. By the time I want to explain that circuit, you will not understand. So this is a simplified version of that circuit you saw in the last slide. Now you have 3 Duracell batteries. Each of the batteries have 6 volts. When you are connected in series, they are going to discharge 18 volt of potential difference. Now, before they are connected, they are potential difference. 6 volts are stored in these Duracell batteries. They are potential difference. I say potential difference is the EMF when it is not discharging any current. Now, by the time you connect these conductors, these terminals to them, they will now start discharging electricity. Now, Ohm's law states that the quantity of electricity passing through this conductor, this red conductor, from the volt is directly proportional to the voltage and inversely proportional to the current. Now, if you want to take it from this place, let's say this is the current, because this is where 18 volt of potential difference is registering 3 amp of current, and it is passed into this resistance, which are the bulbs. Now, if you want to define it from this point, Ohm's law is saying that the quantity of electricity passing through this conductor is directly proportional to the potential difference and inversely proportional to our resistance. So if you want to study from here, take the red cable as the direct current and the black as the inverse circuit. So in the nutshell, Ohm's law states that the quantity of electricity passing through this red and black conductor is directly proportional to the potential difference and inversely proportional to the resistance. I hope this few points of mine is able to give you a clearer meaning of what Ohm's law is, and I was able to break it down to layman language. Keep watching our videos and keep subscribing. Thank you very much for listening, and bye-bye for now.